Okay, well, welcome back to Griffith Observatory. And our absolutely gorgeous night here in the beautiful city of Los Angeles. Welcome back to you might think, oh my goodness, with all this city light behind us, how can we possibly see the sky? How can we see the planets? But we have this beautiful historic telescope and this wonderful observatory, and it's actually just fine. You can see the planets just fine through city lights. So even if you're in a very bright city, you can go out and take a look. And I hope some of you had a chance to just go out and look out the window, or go into your backyard, or go out onto your fire escape, or wherever it is that you live, get a chance to take a look at the beautiful night sky that we have tonight. We have an amazing set of guests tonight, so we're going to be sharing a lot of information with you tonight about Mars, about NASA's exploration of Mars and all the things we've learned. We also have a lot of people from different sci-fi television shows here. Some of you might be fans of Star Trek or The Expanse or The Orville. And so we have some writers and actors from those shows who are going to be joining us in a little bit. And so we hope you'll stay with us and keep it in the background. Watch Mars. As Mars gets higher and higher in the sky, the view will get better and better. As you can see from the little picture-in-picture here, it's kind of wobbling all over the place. And that's because it's pretty low to the horizon still. It didn't, as you can see, from rise long ago, and there's a lot of atmosphere. And that's because it's pretty low to the horizon still. Heat in the atmosphere as it cools that's causing the image to wobble. But through the night, the image will get higher, and it will get a little bit better. So one thing that the image won't look like is this. I can't believe it, but sometimes these things have a life of their own. This is the hoax that's out there that says Mars will be as large as the full moon. That is absolutely not the case. It will not be as large as the full moon. So, but what will it be? Will it be that spectacular? I mean, it's kind of cool knowing that it's as close as it will be for the next 17 years. But what does that mean for how it will look? Well, as you can see, between this opposition and the next opposition, the actual apparent size and apparent brightness isn't that big and that different. But this one's a little bit closer, so it is a little bit brighter. On the downside, though, Mars is on has a little bit of a tilt to its orbit around the sun, and at this particular opposition, it's down there on the southern end of the southern part of the ecliptic. In other words, it's south of the equator for us, and in fact, it's about how many degrees south, Tony? It's about
26
almost 26 degrees south. So it's not the best view that we could have, but it might. We will be looking at that part of Mars that's lit up over here on the left. As you can see, we just left this up here because we like the fact that we have cycle, so whatever's lit up in the daylight there, with these very recognizable three volcanoes and then huge Olympus Mons, and the beautiful Valles Marineris Canyon. Kind of the most recognizable face of Mars is actually the face that's going to be facing us. So through the course of the evening, Mars turns on its axis, and we will lose part of Valles Marineris, but we'll always have Olympus Mons, and we will lose part of Valles other volcanoes in view. So, hey,
but will we see them?
But will we see them, exactly. This is a picture taken from Hubble at Mars, and you can see this very recognizable pattern. What's the name of this region?
It's Syrtis Major,
Mars,
the
and you can see this very recognizable pattern.
Okay. And the round thing down below the bright area is called Hellas.
Hellas Basin, okay? And it's a big impact
thing
crater.
down below the lowest elevation, Hellas. And then the thing looks like an arm going out to the left. Has Sinus Meridiani, which is the 0-degree longitude of Mars.
Great.
Also is where opportunities near that area.
Great, we'll show where that is in just a few minutes. But you can see the last opposition. We're looking at the same face of Mars that we were but you can see the last 2 years ago, but there's a huge difference. So why 2 years ago was it so great? And this time it looks like just kind of an orange blob. You can barely see anything.
2 years ago,
And
was it
this
so great?
is the reason.
And
There's
this
been an
time it
enormous
looks like just kind of an
dust
orange blob. You
storm
can barely see
on
anything.
Mars.
And this is the
so
reason. There's been an enormous
what you want to
dust
do?
storm
Oh my gosh!
on Mars.
What you want to
And
what you want to do for the next slide is get out your 3D glasses, because this is actually a 3D image of Mars. And if you look at it closely, you can go back to the image. Because this is actually a 3D image of Mars. And if you look at it closely, dust storm, you can go back to the image. You should be able to piling up on the front of this dust storm. So, Tony, why don't you tell us a little bit more about this? It started in April. That picture started from April.
Yeah, until April, Mars looked very clear and promising. People were seeing and photographing lots of detail on the surface. Until April, Mars looked very clear and promising. Bare, dark Martian rock is visible. But at the end of May, all of a sudden, a huge storm, dark Martian rock is visible, which we saw in at the end of May, right-hand image, a huge storm, and then appeared. The storm spread, right-hand image, and then we see a brightening and covering some of the features. Now, here's the other side of Mars, and on the left we see it before the storm, and on the right we see that on the left edge. Here's the other side of Mars, and on the left we see it before the storm, and beginning to do things like fill the Valles Marineris. So now it looks like a bright finger in the center of the planet, and that's actually the deep valley now filled with dust.
So right there, so it's dark normally, but here it's bright and filled with dust.
Yeah.
So right there, so it's dark normally, this grew over the period of time. And tell us about this amazing map.
Yeah, so this is from the Mars Reconnaissance Orbiter, one of the instruments on it. We see the spread of dust from the near where Opportunity is sitting, and Opportunity is about a kilometer and a half lower elevation than the average height of things on Mars. So it got kind of buried early in the dust and is still in it. Things on Mars. So it got
although not literally buried, it's figuratively buried.
It's still in it. But it's on the surface of Mars we can't see now because it's obscured.
It's figuratively buried.
So the surface got very, very, very dark.
And
this is a simulation done by a Jet Propulsion Laboratory. What the skies looked like from the Opportunity spacecraft as the storm came up and made things darker and darker and darker. This little graph shows you the transparency and of the atmosphere over time. This was one year when they had a big storm.
It was 2007.
In 2007, but then look at this, boom, this green line goes up. Just terrible, terrible opacity, a lot of darkness there.
And then the data stopped.
And then the data stopped, that's right, because poor little Curiosity, just poor little Opportunity just had to shut everything down, because as you can see, it has solar panels on there. If we could go back to the picture there, it has solar panels on the spacecraft, and so without any sunlight, you're not getting any power, so it had to really hunker down. And so we have here, so David Reitzel, who's with us, goes, can go back to the picture, please? David Reitzel has goes every year to Burning Man, so he was hoping that maybe Curiosity was similarly outfitted and ready for
prepared for the dust, and has its goggles on and its respirator on.
Similarly outfitted.
But we haven't yet prepared for Opportunity, and we'll hear more about that later tonight.
More about that later tonight. So David, tell us about this.
Yeah, this is a view from Gale Crater. Curiosity took these real images, and you can see the rim of the crater is being blocked by all that dust. Its respirator on. But we haven't yet to hear from poor Opportunity, and we'll hear more about that later tonight.
More about that later tonight. So David, tell us about this.
Yeah, this is a view from Gale Crater. Curiosity took these real images, and you can see the rim of the crater is being blocked by all that dust that's in the way. In just 3 days, the view got much worse. Now, luckily, Curiosity is able to continue its work, however, because it's not solar powered. It has a different power source. It's nuclear powered. So Curiosity's working through the dust storm, but as you can see here, it's crazy. On the view on the left, kind of normal image, that's a drill site, and on the right-hand side, that deep red, that's the light that's getting through that thick dust. It's like the sun passing through smoke getting to you at sunset, for example. Well, now it's constantly only the red light getting down to the surface. So Curiosity can work, but it sure looks a lot redder than it normally does on Mars. Here's a view of Curiosity there at the bottom of the Gale crater, and you can see in the background the dust that's there.
So Mars has been very dusty. It continues to be very dusty. So I like that picture with our little picture-in-picture in the corner. As you can see, there's not a lot of features on Mars. We even had the South Pole, even its polar cap is covered with a lot of dust. And this movie shows the difference before and after the month of June, what a difference a month makes in looking at Mars through a telescope. So this was just about 2 weeks ago. Again, just very little visibility. And then, Tony, you want to tell us a little bit about this one? I think
this is a view from Chile through a 40-inch telescope there by Damian Peach. And again, you can see some of the dark features, which are normally what you'd like to look at through a telescope, but they look like they've been painted over, by a thin layer of paint or something, and they're really hard to see.
Yeah. So, so that's as good as we can do through a telescope now. So, I would like to have Patrick tell us a little bit more about what it's like now to explore Mars by going there with spacecraft. So if we can start, Patrick's going to tell us a little bit about the history. We've had a lot of spacecraft go there. We're going to have just a little quick run through of some of the various spacecraft that have visited Mars. It all started way back in the early 60s.
That's right. And starting with Mariner 4 and Mariner 6 and 7, these were the first spacecraft that flew successfully past Mars and took a few images. And then after that, it was followed by spacecraft that actually slowed down and then went in orbit around the planet Mars. And the first successful attempt was Mariner 9 in 1971, and that was when it actually flew and then got into orbit around Mars. Mars had already been enshrouded by a great dust storm, similar to what we see tonight. And then the Soviet Union had 2 attempts with Mars 2 and 3, and then finally Viking 1 and 2 and Mars Global Surveyor. Those spacecraft went around in Mars and are currently obviously not operational at this time.
But there are several that are in operation right now. It's amazing to look at the fleet of spacecraft around Mars.
That's right, and there are 6 of them. The first one's Mars Odyssey through to Mars Reconnaissance Orbiter were mainly survey spacecraft, mapping and photographing Mars, and then the last ones were for atmospheric views. And currently we can see the orbits, and go to the next slide. So there are Mars Odyssey, Trace Gas Orbiter, and Maven all closely orbiting Mars, and Mars Express having a wider orbit, and the furthest one is Mars Orbiter mission, which is a space mission launched by India.
So, of course, there aren't just spacecraft in orbit. There are several that have landed, and so landers and rovers. We've got the Viking.
That's right, Viking, and then 1 and 2, and Sojourner was our first rover, and Spirit, which is not in operation, and the Phoenix lander in the polar regions. Those are the past missions on the surface of Mars. Currently, there are 2 that are in operation. And go to the next slide. And that's Opportunity, which is experiencing that fierce dust storm. And Curiosity also is in operation. And we can go to the next slide. And so en route to Mars right now is Mars Insight, which will be landing on the 26th. And then further afield is Mars 2020, which is a rover that will explore Mars.
So here are the positions of all of the missions that are there, and InSight is the one that's going to be landing there this year, launched just a few months ago and landing this fall. So with that, I would like to come back, and we're going to bring out the head of the Mars Exploration Program from the Jet Propulsion Lab in just a few minutes. So if we can go to Mars's picture, we're going to hear all about those missions and some of the great discoveries from Dr. Rich Zurich from Jet Propulsion Lab. So let's go listen to a little music while we bring Rich in, and we'll be back with you in a few minutes. Okay, welcome back to Griffith Observatory. A gorgeous, starry, city light-filled night evening with a beautiful view of Mars right behind us.
Right behind.
Right behind us. So close you could almost reach out and touch it. And only about 35.8 million.
You have to have a long arm.
Yeah, that's right. Or a spacecraft, which is what we've done. What an amazing history of Mars exploration we've had. And you've been a part of it for quite some time. Do you want to tell people a little bit about your background? How did you get into this business, and what are some of the projects you've worked on?
Well, I actually am an atmospheric scientist, but Mars has an atmosphere, and so we need Mars meteorologists like we do on the Earth. I actually came to JPL when Viking was landing on Mars. A very exciting time. Here was 2 orbiters, 2 landers, deployed from orbit, setting down on the surface for the very first time successfully. And so that was a very exciting time.
And that was a while ago.
Yeah.
Yes,
right.
So you were a young Dr. Rich Zurich.
Yes.
And
it's amazing how fast these years go by. But there was a time when we weren't doing very much at Mars. And
Start to get static on this one.
okay. So there was a time when we were not doing very much at Mars, and that was after the Viking missions, and there were other things to do at the time, but we also thought we needed to get back to the planet. And when we started doing that, we started with the Pathfinder mission, and it had a little rover, and that was the first of our landed things going out, setting down on the planet. It didn't go very far, it sort of did ring around the lander itself.
so how big was Sojourner rover? Is
About
it
the
about the size
of
of
a
this
bread
table?
box. That's right.
A bread box, so it would
Yeah.
fit on this table.
It would indeed.
Oh my goodness.
So a very small thing, and nowadays we fly things that weigh a ton to go out to the planets and sit down, and that's Curiosity now roving across the surface of the planet. We also put down a couple of rovers that were supposed to be just 90-day wonders. We weren't sure if we were going to do this, that we were landing them in airbags, which would deflate, and then the rovers would go out onto the surface, off of the platforms and such, and explore. Well, that was a 90-day mission, and that was 13 years ago for the Opportunity rover.
It's been a long 90 days.
It's been a long 90 days. So I think, although the warranty is up, they kind of outperformed their specs for just how long they might go on the planet. So right now, there's a lot of spacecraft at Mars. We got the 2 rovers on the surface. Although Opportunity, as you've noted, is in hibernation right now, waiting for the sky to clear so that we can get enough power to call home again once it's charged up its batteries.
Now, what is the prognosis on that? Or is it going to come back to us? Or are we? I know everyone's holding their breaths, but what do you think about it?
I'm optimistic, and the reason is that one of the things you need power for is to keep yourself warm. And actually, during these dust storms, the nighttime temperatures, which are the coldest, just like on Earth, they're actually warmer because the dust sort of acts as an insulating blanket and keeps the ground a little warmer and such. So what we need is the sky to clear up in a hurry so we can charge up the panels before the temperatures drop again back to what they would be. Fortunately, Mars is getting closer to the sun, although tonight it's closest to the Earth, as it will be for some time. It will get closer to the sun here over the next couple of months. It has a very elliptical orbit, and that warms it up a bit. So we're very hopeful that we'll get a call home. That might not come for another month, because it may take that long for the dust to fall out of the atmosphere. This is very fine material that's being lofted up into the sky, and some of it is going up 40 or 50 miles into the sky. So it takes a while for it to fall out from those heights and stuff. But the good news is it looks like the storm is beginning to clear up. We're starting to see some of those classic surface features like Syrtis Major appear through the murk again. But it's still going to take maybe another month or so before Opportunity will have enough power to call home. And part of that is we don't know how much dust will fall on the arrays and stick there before it gets blown off. But it's an Endeavour crater, which is one of the windier spots on Mars, so we're hopeful.
I seem to remember there was a time when the solar panels were covered with dust, and a dust devil came by and cleaned them off. Am I remembering that correctly?
You are indeed. There's been several so-called cleaning events. And in fact, just before this dust storm, they were almost back at some of the original power levels back many years ago. Well, the dust storm changed all that, of course. But a lot of that dust is in the atmosphere now, and as it falls out, if we just get a little wind blowing around the rover, it'll keep the arrays clean enough. So we're hopeful.
Great.
I don't want to underplay. It is serious that when you have a solar-powered mission, this is what can happen.
Yeah.
The sky can get dark for weeks, and now it's going to take another month or maybe 2 for that dust to clear up.
So Curiosity's not suffering really the same fate because it doesn't rely on solar panels.
Nuclear power can be a very helpful thing on a dusty planet. And that's what we're dealing with on Mars, is that a lot of dust. And these storms, though, don't happen every Mars year. In fact, we've tried to estimate, based upon some of the telescopic observations, like people looking at the planet tonight, just what those are. But because you tend to look, when you're looking with a telescope from Earth, only when Mars is close to Earth, that means you're not watching Mars all the time. And so to change that, we've put orbiters into out to the planet, and now they can go around the planet, and they can show us. Each day we can get a daily global map of the entire atmosphere, and that's what the Mars Reconnaissance Orbiter is doing. And even then, it's also taking the temperature of the atmosphere so we can see the effects of the dust as well.
Yeah, we have the slide, if we can just show the slide, of all of the orbiters that are currently, it's a flotilla.
It's a flotilla.
Of spacecraft all around Mars, all operating, working together. And if I'm not mistaken, some are actually acting as relays to help communicate with the ground as well, yeah?
Indeed. The Mars Odyssey spacecraft and the Mars Reconnaissance Orbiter are routinely relaying data from both Curiosity and, when it's sending information, Opportunity. And the other missions, like MAVEN and the Trace Gas Orbiter, which are newly arrived, they've both been equipped by NASA with devices that can relay those signals back.
Yeah.
And the advantage here is that the orbiters can have great big solar arrays. They're not subject to the dust blowing around in the atmosphere. And so they have plenty of power to send all that data all the way from Mars back to the Earth. So that the rovers only have to send it 180 miles or so up to orbit. And then the orbiters can relay it all the way back to the Earth, which can be from 35 million to well over that when Mars is on the other side of the sun.
How far do we get when we're as far apart? If tonight's the closest approach, what's the farthest distance that we get from Mars?
Well, you add the Earth's orbit, and you double that, because if Earth is on this side of the sun, so that Mars is lined up, but on the far side of the sun, now we're talking about 240 million miles. So it's
8 times farther away.
It's further away.
And it gets very small in a telescope.
And so most people don't look through their telescopes at that time. But with our orbiters, we got the same view every day flying over the planet.
Now, you mentioned MAVEN, and MAVEN just had a new result. And can you tell us a little bit about MAVEN and what its mission is?
Well, each of our orbiters were sort of designed to look at particular aspects of the problem. And I mean, an obvious question is, why are we studying Mars? And one of the things we want to learn is we think the climate of Mars has changed from a more Earth-like climate very early in its history, literally billions of years ago. And that climate was wetter, the atmosphere was thicker. And so the question is where did that atmosphere go? Because today, that atmosphere is less than 1% of our own atmosphere here on Earth. So where did that atmosphere go? One idea is that very early on, Mars had a magnetic field like the Earth, and that magnetic field sort of holds off the solar wind from sweeping into the atmosphere and accelerating some of the molecules that are in the atmosphere out into space. Mars lost that magnetic field, so the solar wind could dip in. And over billions of years, it stripped away until today's remnant atmosphere may be only 1/100th of the original atmosphere on the planet. So that's really counts. And yet understanding the process, because what we want to do is we want to extrapolate back over all that time to when Mars might have had this more massive atmosphere. How thick was it? Was it wet? Where did the water go that was probably in that atmosphere? A lot of it has been lost to space. And the other place that the water may go is frozen into the ground today. Unfortunately, liquid water under most Mars conditions today isn't. It's either ice or it's vapor in the atmosphere, because water on Mars acts like CO2 in the Earth. It goes between the solid and the gas phase as temperatures dictate. So MAVEN has been looking at this process today, and if you take just one set of the molecules that are being stripped away, the sort of charged particles, it's about a quarter pounder a second being stripped away from the planet.
Well, that's an easy way to remember it. That's a visual. If we were at All Space Considered, we'd be having quarter pounders flying off of Mars. You know, we've been talking about the change in Mars's atmosphere and how it can't hold water on the surface anymore. And there's a really fundamental reason why we want to know about this wet earlier time on Mars, and maybe you could say a little bit about that. I mean, we're spending all this effort, we're so anxious to find water on or in Mars, and we'll come to that in a minute, but why is that? What's so important about finding water on Mars?
So finding water, liquid water, any place in the solar system, we think water is essential to life as we know it. It's an agent of climate change. It erodes the surface and rocks and such. And finally, with Mars, it could be a resource for future exploration by people down on the surface of the planet itself. We don't want to haul all that water to Mars if it has its own resources. So if it has ice in the near surface that we could dig up or tap into, that would be great, because then we can change that water into fuel, into oxygen to breathe. It would be a real resource for us. But our real thing is did life ever develop elsewhere than on the Earth?
Yeah.
Where in the solar system could it be? And Mars is one of those more Earth-like environments, particularly in that early history before its climate changed, where life might have gotten a start, a hold. And so the question is there any evidence in the surface today of that ancient life, the origin of that? Or is it possible that there is even life on the planet today, probably in the subsurface, buried a few meters below, where it's protected from the radiation that otherwise would get absorbed by a thicker atmosphere? So there's plenty of reasons to think that Mars might be this abode of life. We talk about habitability, and the Curiosity rover and Gale crater has measured the essential elements of life, and we know there's ice, so there is water in places. But the question is it inhabited? And that we don't know, and so we still search.
Well, if you've just joined us, I'm talking with Dr. Rich Zurek, who is the chief of the Mars Exploration Program at Jet Propulsion Lab. So he's the guy to ask the question that I know I get asked all the time, and I'm going to do it to you. I'm sorry, I'm going to ask you, but do you think there's life on Mars?
It's a different life, if that would have to be there today, because we don't see anything on the surface itself. You know, we can see from orbit, we can see the tracks of the Opportunity and Curiosity rovers, and we haven't seen any sign of something that we would confidently say is an artificial structure. So if there's life, it's microbial, and it's most likely in the subsurface. So where do we go look? Well, there are certain places on Mars that are sort of just very mysterious in the effect that the albedo changes, and we're not sure why. Maybe there's a little bit of water that wets it occasionally. And so those may be spots where we eventually go and dig down and look for that life, or find some other way to look at. And one way that we're looking now is to look at the trace gases in the atmosphere. On Earth, most of the methane in our atmosphere actually comes from living organisms. Now, there are other processes, mineral transformations, that can produce it too, but go look for those trace gases, and if we can find a source, then we could go digging.
Yeah.
And that would be a guide star for a future mission to go.
So we've had all these wonderful missions. We had the flybys, the orbiters, the landers, the rovers, and we're about to have InSight, something that's going to dig down about, I think, about 16 feet. That thermal probe is going to go in. Am I about right on that?
That's
yeah.
right.
So we're even getting inside the surface of Mars. So what's next? We've got this amazing set of spacecraft. We have learned so much. As you said, we've learned that there was liquid water in the past. There's water in other phases there now. It has the right elements for life.
Mm-hmm.
It certainly has the energy source. So what's next to discover, and what's NASA going to do in the next couple of years?
Well, when you think about all the experiments you'd like to do in looking for life, that's not an easy thing in an environment we're not really sure what all the elements and what it's like. So instead of trying to take our most sophisticated instruments to Mars, why don't we bring a piece of Mars back to Earth, where we can analyze it in the very best laboratories that we have. And not only that, but when you get a surprise, a discovery, you can design a new instrument. You don't have to wait to build another mission that flies out to the planet and then eventually does that experiment. You can do it because you have the sample right there in the lab.
So we're going to send a couple astronauts with shovels and a pail? Is that the plan?
Well, we thought first we'd send a robot, make sure that we could return the samples from Mars before we try to return humans from Mars. Seemed like a better part of things to do. And this would be the first time, actually, that we're going to send another rover that's built on the same kind of robotic chassis as the Curiosity rover. So we're taking advantage of all the technology that went into developing that.
And is it going to land in that same way, that crazy sky crane, and it drops it down?
Right down there on the surface.
Yeah, we have a video of that we'll be showing a little bit later when we talk about Curiosity.
That's one of the great things about the space program draws out that kind of innovation. Because the first time somebody described that to me, I said, no, that can't be right. You wouldn't hover and try to lower something.
What maniac came up with that?
Exactly. But it actually solved a number of problems. And it's a platform that we can actually land that rover, or a landing platform, and that platform will have an ascent vehicle on it. And that ascent vehicle will eventually be the one that takes those samples back into orbit. So first, we've got a rover that's going to land just like MSL did. It's going to rove across the surface. It's going to take samples, maybe as many as 20 to 40 of these samples, and then some of those will be selected for a return to Earth. Second mission will land. We're still working out some of the details of that. Maybe we'll use the sky crane system. Maybe we'll use something more like the Viking spacecraft, where they just land on the thrusters all the way down to the ground.
Yeah.
That will carry an ascent vehicle, and we'll be launching from the surface of another planet for the first time.
Kind of like we did when we went to the moon. Yeah, exactly. Yeah.
But now we'll do it from a different planet
Yeah.
out there in the solar system.
So exciting. And not too far in the distant future?
We're hoping that we might be able to, so the rover that will put we'll get the samples and drill those out of the rock and such, that will go in 2020, land in 2021, and we could get this fetch rover and this ascent vehicle down on the surface in 2026, if we decide that's where we're going to go.
That's
go
cool.
forward with it in that time frame.
Less than a decade from now, we might be doing that.
So,
and I like the name Fetch Rover. That gets all kinds of ideas flowing.
Now, we're talking with our international partners because, as you've noticed, Mars has become an international destination. Of the 6 orbiters that are there now, 3 of them are actually from other countries. 1 from India, 2 from the European Space Agency and its collaborating nations. So this has become a destination for international efforts. And when you have these various missions that are needed to get the samples all the way back to the Earth safely, then a little help from our partners will be good.
Rich, it's been really wonderful to have you here tonight. Have you had a chance to look through a telescope yet?
I have.
Oh, good.
But I saw Jupiter. I want to see Mars, so I'm going to go take another look.
Well, Jupiter looks beautiful. You can see the red spot, I'm told, tonight. But we want to thank once again Rich Zurich for being with us from NASA's Jet Propulsion Lab, the chief of the Mars Exploration Program there. And so we're going to take just a minute or two and have a little break with some music and a few look at Mars. Then we're going to come back with a special surprise guest that we've talked about on our social media. I think I can go ahead and say who it's going to be now because it's not a secret anymore. But we're thrilled to be welcoming astronaut Buzz Aldrin to join us here and talk to him a little bit about his vision for getting back to Mars. So with that, I'd like to go to the picture of Mars, a little music, and we will be back with you in just a few minutes. welcome back to Griffith Observatory on our beautiful night here with gorgeous Mars behind us, within reach, as we were saying a little while ago. And I am thrilled and honored beyond belief to be sitting next to the second man to walk on the moon, Buzz Aldrin. So welcome to Griffith Observatory, Buzz. And we're so happy that you're here.
Well, it certainly is nice to come back here.
Yeah.
You sort of forget where you've been, but then when you get there, oh, yeah, I remember all about being here.
Yes, it's a beautiful, unforgettable building, and it's a wonderful night here. I was saying to Buzz just in the break before we came that I saw an interview with him not long ago where he has said he had been to the moon, nothing but desolation, magnificent desolation as you described it, but nonetheless desolation. And really not a great place to set up camp. Would you agree with that, or do you think we ought to be...
Well, I think that at the time, Neil's words were contrasting a small step per human being. And what he meant was that mankind has just expanded so much. But after that, a lot of people felt, well, that was a small step, but when are we going to make the giant leap? And of course, we've been assuming that that would become Mars. Anyway, he had a couple of really good phrases that he could use. So I wasn't really conscious of it, but there was a word beautiful used, and boy, I didn't think it looked beautiful to me. So the contrasting words were magnificent, desolation. I mean, the magnificence of humans being able to be there and look out on just how desolate this is. You couldn't create anything on Earth like that.
So if you wanted to go somewhere in the solar system next, would you want to go back to the moon, or would you want to go to Mars?
Well, after the moon, I began looking at a free return from the moon, which would bring you back. We never had to do that, but it would bring you back, and you could swing around the Earth and go back out again. And that led me to something that could repeat back and forth between the Earth and the moon. And I thought that's pretty smart.
Yeah.
I knew that it was to have a view of what's going on. It wasn't a way of transporting people to the moon, because lunar orbit rendezvous clearly was the best way. But NASA wasn't interested in this anyway, so I went back, and Tom Paine, who was the administrator of NASA when we went to the moon, he was in Santa Monica, and he said, "Buzz, don't get disappointed. Why don't you look at gravity assist between Earth and Mars?"
So it
I
was
thought,
Tom
wow,
Paine
that's
who
difficult.
set you
But I
up.
looked at it, and no, it's not that difficult. I mean, after all, the Agena target vehicle in Gemini is going around, and Gemini is catching up to it around the Earth. And here's Mars going around, and the Earth is catching up with it around. Same thing.
That's what rockets do, right?
Yeah. So, well, the orbital mechanics is similar, and you can get a good bit more involved, but there certainly are ways that you can have a pathway that continuously swings by the Earth. You could get on it. Swings by Mars, you get off of it.
Oh, perfect.
And then two of these will. So that is has been what Purdue University and I began studying 4 or 5 years ago. And of course, we were using lunar propellants to be able to carry out those Mars missions. So a year later, we began looking at specifically the assistance of the moon for the Mars. and just how habitats on the moon could lay the groundwork for Mars. And I've eventually looked at the most critical, which is refueling a rocket that lands on the moon. How can we refuel it? Not in orbit, but it's so much easier to refuel it on the surface. We've got a depot that lands here, lightweight, low on fuel, take the cargo off, move it over to a common refueling area. Now we got the depot, so back and forth goes the routine
And
surface tanker.
I see.
So,
And
I mean, you make that routine. You can do it here on the surface of the Earth with mock-ups. And you have segments. You finish one segment, then you proceed to the next one.
And then with that, from
You can
there to Mars.
refuel. You can refuel the moon from mission control here on Earth. And if we make things similar to that, we can refuel rockets on the surface of Mars.
I see.
Right from mission control on the Earth. Just think of what that does
Yeah.
for reducing the cost of how many landers are going to have to go.
So you see a day when all of this infrastructure is there, so travel to Mars and
Absolutely,
work
and
on
that's
Mars and life
exactly
on Mars is routine.
What I've been modifying, what we have right now, which is too expensive, and it's over budget, over cost, and we have to phase these things out and come up with new adaptations of equipment.
Yeah.
I could go into details of this, but
Well,
not that
moving
many
off the
people.
technical part, I want to know why. Why should we go back to Mars? Why do you think Mars, not back to Mars, why should we go? Why should humans go to Mars? What's so important about that,
Well,
do you think?
we should establish an occupancy on the moon. Somebody's there all the time. And Jeff Bezos, with his Blue Origin and Blue Moon, clearly is interested in setting up an industry based upon refueling at the moon and the materials that are there. And he will begin to finance this by suborbital flights for tourism, then orbital flights, and then this out from Earth and around the moon and back. And you could even take a tourist, well, I would call them now a Space View Voyager. Space View Voyager.
Sounds good.
You could
Count me
take
in.
this crew on a new craft that just goes orbit to orbit. Now, they go along with a new crew that's going to go to the moon. And now we've got this tourist along with them. Now, the new crew is going to get into a reusable lander, and the old crew from the lander is going to get into this spacecraft, and they come back.
Yeah.
So this one observer gets into lunar orbit and sees a new crew getting in and the old crew coming. They see this rendezvous taking place in orbit around the moon.
Let's say that.
Now, one
you or
more
as me.
step and we'll land them.
Okay,
but
good.
that does get pretty expensive.
Yeah.
But
But
just
that's down the
riding
line, don't you
along
think?
with the ordinary exchange of a fresh crew for an old crew, now that makes occupying the moon rather simple. The new crew and the old crew, it's an exchange.
Yeah.
That doesn't happen at Mars.
It's a little too far away.
No, you can get there by leaving before opposition, arriving after opposition. Now, if you wanted to come back, you'd have to leave Mars before opposition. So you can't leave and both places at the same time. You got to wait 2 years.
Yeah.
So if you go to Mars, you're there for 2 years or a year and a half.
So that's
now you can occupy Mars, but the first crew has to stay until another crew gets there.
I understand.
Now, those are not too desirable because I believe we will decide by 2025 that not only will we occupy Mars, where U.S. leadership of a coalition of capable nations will occupy, but I believe that we will upgrade that to migrate. Now, migrate these days means no deportations. Now, if you say I'm going to settle, you can visit a couple times and then decide to settle. Colonize, same way. You can visit and say, I'm going to colonize. But the word today, I think, is when you go there, you're going to land and you're a migrant. You're going to land and stay.
Buzz,
otherwise, you're not going to go in orbit. You're not useful in orbit.
Yeah, nothing to do there. Got to go to the ground. You need to go grow potatoes like they did in The Martian. So let me, I would like to indulge myself one moment before we say goodbye to you, simply because not only do we have beautiful Mars behind us here, and I don't know, maybe Jared, you can count
pretty close, too.
Amazingly close. But turning my back on the camera here, to the left, to the east, the moon is also...
Well, I saw it was orange coming up.
Yeah, wasn't it?
But that's not quite the blood moon.
Not quite the blood moon.
When does that happen? Next January?
That was, there was one just a couple days ago.
I know, but not for us.
Not for us, unfortunately, yeah. So it's something to look out there. Look at the moon, look at Mars. Think that, you know, the distances may seem great, but not so great that we can't cross them. We have proof that we can do that. You've gone to the moon, you've been there yourself, you see a vision for Mars in the future, and I think that's one that a lot of people out there share with you, and we'd like to see happen.
There is a science investigation to be done, and those were done somewhat at the moon, but it takes a human with judgment to be able to get the return out of visiting. But we had 2 guys for 1 day. 2-3 months later, 2 guys for 1 day. We ended up, as I said earlier, 2 guys for 3 days.
Well,
but those are visits with long time. We need to occupy, and we need to occupy the moon while we are preparing with those lessons to begin to land and stay on Mars. And the people who do that will have gone to the moon for 2 or 3 months, come back, so they know what they will be committing themselves to do. Now, I've had an awful lot of time in the last 40 years, 30 years, 10, increasingly to think about these things. Yeah. And as months go by, and I see what I add more details to the things we need to change. And fortunately, being a part of the National Space Council, the user advisory group, and I have some good connections there, I think that the opportunities to reach the space program with innovation How do we get innovation? Through a human spaceflight institute that I'm putting together to evaluate innovative ideas, and then have universities look at these ideas and make judgments. Then we'll smooth out these and pass them to NASA.
Come forward.
Put professional papers,
I want to thank you for your leadership on this. I know you've been an outspoken proponent and cheerleader for going beyond the moon and taking this next step, and the real tangible work that you're doing, creating this institute and developing these very concrete plans is a wonderful legacy to leave and a gift to the next generation who will be the ones to travel. So I'd like to thank you for coming here tonight and being part of this, and for indulging my my wish that I get to stand and sit next to someone who's actually walked on the moon and look at the moon side by side with you. Well, it's been a real thrill to have you here.
I had a Share Space Foundation. It was for tourists and lobbyists, lotteries. That didn't come about. Scholarships, STEM education, and eventually lower, 4th and 5th grade. But then when people in my organization started having fundraisers for inspiring future game changers, I said, wait a minute. I'm the game changer of the present. We have to get behind what I'm doing, and that will inspire the next generation.
We need to be the game changers for the present. So with that, I would like to thank Buzz again for coming and go back to our view of Mars, let people look at humankind's future abode, because if all comes to fruition, as we hope that it might, we will sometime be up there, and I'm willing to bet there's going to be the Buzz Aldrin Institute for Martian Study on the surface as a memory and a thank you for all of your leadership in getting us beyond the moon and onto Mars.
Well,
so
there are two things we need. We need patience, and we need money.
Patience and money. Please, can I have patience and money? That's a wonderful thing.
That's budget.
Yeah, thanks so much.
Very welcome.
Well, welcome back. We still have Mars in view for you in the lower right-hand corner, but we wanted to take an opportunity to say, yes, in the lower corner, yeah, look, we have a little screen we're looking at. But I wanted to take an opportunity to celebrate two people who are here with us tonight and introduce them to you. We probably don't need a whole lot of introduction. On my far left is Tim Russ, who, if you are a fan of space and astronomy, you probably recognize because he played Commander Tuvok on Star Trek Voyager, a Vulcan no less. And in fact, Tim was here at All Space Considered a couple of months ago, maybe about 6 or 7, 8 months ago.
It was like February, I think.
Yeah, it wasn't too long ago. Yeah. It was wonderful to have him join us, so we're thrilled that he's here. And next to him is Andre Bormanis, who is a writer and television producer, writer, and started out as science advisor to the Star Trek franchise way back at the Next Generation. And both of them are here because both of them are avid amateur astronomers. And I guess the first question I have to ask each of you is, how many telescopes do you have?
I've got 4.
I think I lost count after I bought my 10th or 11th.
Oh!
But, maybe a baker's dozen. Some of them are historic and sort of, you know, nostalgic.
Haven't looked through them lately?
Have not.
Yeah, what do you do with 12? You don't have 12 eyes or 4 eyes.
Well, I use they're optimized for different kinds of viewing. One of them is an antique. It's an old Alvin Clark 4-inch refractor from the early 1890s, still a brilliant telescope. And then, as Laura knows, I had a very close friend and mentor, a man that I met when I was a child who was a brilliant optician and built telescopes until he was in his late 80s when he passed away. And I have several of his telescopes that I've collected over the years. So, yeah.
Yeah. And why? Seriously,
why?
What is the draw? I mean, we're all doing it. There's this, view of the telescope here.
Yes.
What is the draw? What is it that makes you get all that glass and spend your nights doing these crazy observations?
By the way, we're the guys who get to follow Buzz Aldrin. So thanks, Laura. Friendo 20 years. But, no, it's a legitimate question. Buzz is amazing. But I will tell you my story, and then Tim will tell you his. But when I was 11 years old, I was really interested in astronomy. I lived in Phoenix, Arizona. I could see the night sky pretty well back then. And so I decided I wanted to get a telescope. And I looked in the phone book in the yellow pages under telescopes. There was a company called Ad Astra Telescopes, first listing. So I called them, and I spoke to this gentleman, Max Bray, and I thought I knew what I was talking about, right? And I said, so what kind of telescopes do you make, reflectors or refractors? And he said, oh, I make a telescope that's a combination of both. I'm like, oh my God, what could that be? So he said, have your dad bring you down to the shop one of these nights and I'll show you. And he made telescopes like this Questar that's sitting behind us, a mixed mirror lens system. And he had one about the size of that telescope. He pointed it at Saturn, and I looked through the lens and I saw this little white dot with this little ring around it, and it literally took my breath away. I remember gasping. This was 50 years ago. I remember it like it was yesterday. And I was hooked. And from then on, I knew that I had to do something that involved astronomy, space science, the excitement of the Apollo missions, which were going on at the time. So, I would say if any one particular moment fixed my interest, that was probably it.
Myself, I started studying astronomy on my own with a very small 4-inch reflector, a Newtonian. I decided one day I wanted to, discover and learn the constellations of the night sky, and just, teach myself and learn. At the time there were no computers on the telescopes when I bought mine, and I took it out to the dark skies here off the 5 freeway in the north part of the mountains in the hills, and just started learning where the constellations were and some of the objects in them. And then I just, from there, graduated to larger and larger telescopes, and it was really fascinating to me to be able to see, whole galaxies and clusters in these in the constellations, and it was absolutely fascinating. And I just got larger and larger scopes so I could see more and more. And then eventually, I got a chance not only to see the planets, but also the special for me, the very special things like tonight. I mean, it would have been fabulous to not have the dust storm on Mars, but I saw it 17 years ago when it was close approach. I saw all the detail of the surface in my backyard with a relatively small telescope, and I was just blown away. So that, the collision on Jupiter of Shoemaker-Levy 9, to be able to observe that here at the Griffith Observatory grounds with a small telescope yet again, and then Comet Hyakutake, close up with a big Newtonian Dobson. Oh my goodness, those are the moments and the reasons why I have the telescopes I have and why I enjoy this hobby so much. And I'm waiting for the very next special event, whether it's a supernova or another collision or another comet. I'm waiting for the next event. And that to me is what's most exciting about it.
It's kind of amazing. There are other worlds, and they're real. It's not CG. It's not a picture. It's not a painting.
No.
You're actually looking at light bouncing off of the surface of another world.
That's correct.
It's an amazing... Whoa, there goes my mic pack. Am I still... dropped my mic pack. Are you still hearing me okay? Okay, they're telling me I'm all right.
Well, and I think that's a big part of the allure of Mars, because Mars is the only planet in our solar system where you can directly observe the surface with a telescope here on Earth. When you look at Venus, you're looking at clouds. When you look at Mercury, well, it's too close to the sun to see surface detail, even in big telescopes. Jupiter, Saturn, Uranus, Neptune, again, you're looking at cloud tops. Mars, we see the surface, the physical surface of the planet. We can see features that persist over time, and when there's not a global dust storm as we have tonight, but even tonight with the dust storm, you can see the polar caps, you can see a little bit of the albedo features, the darker so-called seas, which are just really kind of coarser dust on the surface of the planet. When that storm clears, which will probably happen in the next week or two, with a telescope like the 12-inch Zeiss and even much more modest telescopes, you can see a remarkable amount of surface features, and I think that's why the planet captured the imagination of so many astronomers going back to, you know, Cassini and Huygens and Robert Hooke. And then, of course, the canals, the so-called canals that, you know,
and the romantic,
Schiaparelli.
The romantic sort of aspect of Mars. Mars has been romanticized. It's been fictionalized. It's been, you know, all kinds of films and stories and books, and it's just something about it. And it would have been, you know, obviously it was at its inception and its creation at the beginning was a lot like Earth. It was a potentially Earth-like planet, and maybe if it had been a little bit bigger, the core had remained a little hotter for a lot longer. Maybe you never know what would have been like. We could have had a sister planet.
And it's certainly, in the grand scheme of things, so much like the Earth, and it's not that big a leap. You know, I don't think that these back in the 19th and early 20th centuries were necessarily going off the deep end in their speculations, because you know what? Life is ubiquitous on this planet. It's not that hard to imagine that another planet with seasons and an atmosphere and, you know, polar caps that at the time probably thought to be water, and or a mix of water and carbon dioxide. Not that big a leap to expect that maybe there was life there once. Maybe there still is today.
Maybe there still is today. We're still looking.
And we don't want to be alone. We would love to find our cousins out there in the cosmos.
Even if they're little microscopic.
Even if they're microbes.
Absolutely. It's my cousin Croby.
My cousin Croby. You know, most of your body is made up of microbes by number.
Maybe
gut bacteria.
True.
Depending on your diet.
Right. So anyway, both of you. Last question. I won't keep you because Tim needs to get back to his telescope, which is down on the lawn. But you both spend time imagining the future and our future beyond this planet. And you heard Buzz talk about, I mean, I love that he jumped straight to the infrastructure. How are we going to make this routine? How are we going to set up, you know, essentially a subway system, you know, a superhighway system that's going to keep all of the travel back and forth? What do you see? What do you see the future, let's say, let me go with 200 years from now.
Oh, my goodness.
Is that too tough a question?
No, I think
Would you rather start sooner, or should we jump all the way to 200
200.
years?
We can give maybe a stab at 200.
Okay.
The show I currently work on is 400 years.
Oh, well, we'll come to that one next. Because actually, after this, we're going to talk with some folks from the Expanse, and that's set 200 years in the future, and that has a very particular vision. So, so what do you think? What do you imagine?
I think that if our, I want to say, sort of political priorities change over that course of time, we're going to see the changes in our planet because of the resources that might be available and because of the population growth. Population growth this century is going to be a big factor. What are we going to do with all the people? What are we going to do with the resources that may be dwindling? How are we going to take care of everyone on the planet in growing numbers as far as Earth goes? And some of the technology that's created and we come up with in advancements in science will aid in that, as long as, like I said, the political direction and intention and priority moves us in that direction and into the whole, and not so much for the individual. I think we are going to be colonizing space at that time. We're going to be living off-world, if not in orbit, certainly on another planet, perhaps Mars, as a colony, and those colonies will grow to much larger sizes, definitely at the end of 200 years. We're going to be off-world. We're going to be expanding as an Earth species, more than likely with genetic modifications and engineering to our bodies to be able to adapt perhaps to the atmosphere and perhaps the beginning of terraforming on that planet. So that's what I think I see coming. You know, I hope that, you know, on the planet Earth that they're not left behind too much, and that we can work on the, you know, the difficulties we have to deal with here on planet Earth.
Yeah, I would agree. I think that the answer is a pretty credible extrapolation of what 200 years of progress along the lines of what we've seen in the last 50 years might ultimately lead to. You know, the thing that it seems to me people underestimate is the challenge of human beings living in a radiation environment beyond low Earth orbit. I mean, even the astronauts who spend, you know, months to a year on the International Space Station, they are physically altered by that experience in a way that is not reversible, and it's not good. It's bad in a lot of ways, for vision, for muscle mass, for osteoporosis. I'd read recently that the Apollo astronauts were drawn from a group of people, test pilots, a large, you know, sample of extraordinarily physically fit people whose rate of heart disease was about 4 times less than the average population. Now, this is a much smaller sample, but all of the astronauts who left Earth orbit and went to the moon, either to orbit it or to land on it, their rates of heart disease are about comparable to the general population. So that trip to the moon, which was no more than a couple of weeks, apparently quadrupled their chances of suffering from heart disease. And I don't know what other kinds of, you know, measures people have looked at, but it's an extraordinarily hostile environment outside of the Earth's protective magnetic field and atmosphere.
Certainly is.
And cosmic rays and other forms of radiation, extraordinarily debilitating. And I think that that's going to be the biggest challenge going forward in the near term, is dealing with those issues. And that might be a genetic engineering challenge more than anything else.
Dare I say tardigrade? The word tardigrade.
Dare you say tardigrade?
It's out there, man. They know that. They know it. The tardigrade. Everything about those little monsters. You take the DNA, you splice it into human, and you are out of Dodge, man. That is the only way it's going to happen.
Makes you wonder where they came from.
It does make you wonder where they came from, because to me, they are the most amazing microbial creature on the planet, bar none,
and
I think.
they look like aliens, too.
And they look like aliens, just to finish it out.
Yeah, exactly. Well, you know, it begs the question, we need to do more research in orbit. We need to understand, and that, of course, is one of the purposes of the International Space Station. You know, I think that research has got to be, you know, ramped up. We need to really understand that if this vision is going to come true. I want to just say before we sign off for the moment to go back to Mars, that when we come back, we will be talking with a JPL engineer who's working on the InSight mission. That's the one that's going to land this November, so we're going to have a chance to talk to her. And then a little bit later, Andre is going to come back. He is also, he mentioned the Orville, works on the Orville. What's your title?
Executive producer.
Co-executive producer and writer. And he also has been working on both seasons of Cosmos, which is, you know, the remake of the Carl Sagan show. So he's got a lot of different experiences to share, in addition to being an avid amateur astronomer. So he'll be coming back, as well as members of the Expanse. We'll be talking to more people from JPL. And so I just want to thank you once again for joining us here, and I hope you enjoy the rest of your evening. I mean, this really, you could not ask for a more beautiful night.
It's a lovely night.
Absolutely
just
gorgeous.
Breathtakingly beautiful
Wonderful.
night.
Wonderful.
So it's something to look up there and think, well, maybe someday, you know, our descendants will be up there.
Yes.
Yeah.
Our robotic representatives are already
there.
When you look at that planet, think about the fact that there are several spacecraft on its surface functioning.
Gathering data.
And a half a dozen or so in orbit.
Yeah.
And maybe some tardigrades.
Yeah, and maybe some tardigrades. And who knows what else.
Right.
A little fellow named Marvin.
Right, and one guy named Marvin.
One guy named Marvin.
In a Roman soldier outfit. I just don't really quite get it. Whatever that outfit is.
Marvin.
So, so anyway, thanks again, both of you.
Very
so
good.
lovely to see you both.
Our pleasure. Thank you for having us, Laura.
We'll
Appreciate
be back
it.
in just a few minutes with more guests. The next one from JPL. So
Thank you.
enjoy a few minutes of Mars and music.
Thank you.